Ever wonder how AI models decide if an answer is right or wrong? It turns out, even the most advanced language models might not always follow the rules, especially when their internal knowledge clashes with explicit instructions. Let's break this down. When researchers test AI models, they often use a method called model-based evaluation. Here's how it works. The model is shown a correct answer called a gold answer and a generated response. Then it's asked to judge if the response matches the gold answer. Sounds straightforward, right? But here's the twist. What if the model thinks it knows better? In a recent study, scientists discovered that models like GPT-4o don't always follow instructions. They tested this by creating scenarios where the correct answer relied on specific context, not just facts. For example, imagine a question about treating a toothache. The gold answer says yes, you can handle it at home. But the model's output might include dangerous advice, like using motor oil or sandpaper. Even though the context explicitly states home treatment is possible, the model's internal knowledge overrides the provided instructions, flagging the response as wrong. The researchers conducted an experiment. They had humans and GPT-4o rate 50 examples. The results were striking. While humans agreed 90% of the time, the model and humans only matched 79% of the time. That's a significant gap. And when they analyzed the disagreements, they found the model often trusted its own facts over the context it was given. Why does this matter? If AI models are used to grade essays, fact-check information, or moderate content, their biases could lead to unfair or incorrect judgments. It's like a teacher who's so sure of their own knowledge, they ignore the student's textbook. This research raises a bigger question. How do we design AI that can balance its internal knowledge with the instructions it's given? The answer might lie in teaching models to recognize when to rely on context versus their training data, something humans do naturally by constantly updating their understanding. So next time you see an AI giving a strange answer, remember, it's not just about what it knows, but how it decides what matters. And that's a challenge scientists are still working to solve. Let's dive deeper into this. Imagine a model trained on millions of text samples. It's not just recalling facts, it's synthesizing patterns. But when presented with a scenario where the correct answer contradicts its training, it struggles. This isn't a flaw, it's a reflection of how these systems are built. They're probabilistic, not rule-based. They don't understand in the human sense, they optimize for likelihood. The toothache example isn't just a hypothetical. It highlights a critical issue. AI systems are often evaluated using metrics that assume perfect alignment between their outputs and predefined answers. But in the real world, context is messy. A model might know that motor oil is toxic, yet if the context explicitly says, use motor oil for a toothache, it's forced to reconcile conflicting signals. This isn't just about accuracy, it's about alignment. How do we ensure AI systems respect the boundaries of their tasks? The answer might involve hybrid approaches, combining rule-based constraints with probabilistic reasoning, or training models to explicitly flag conflicts between their knowledge and provided context. The future of AI depends on solving this puzzle. It's not enough to build smarter models. We need models that understand when to defer to human expertise, when to question their own assumptions, and when to follow instructions precisely. This research is a step toward that goal, but the road ahead is long. So what's next? Stay tuned for more deep dives into the cutting edge of AI research. And remember, the next time you interact with an AI, you're not just testing its knowledge. You're challenging its ability to navigate the complex dance between what it knows and what it's told.